Oxidation number. Oxidation number is defined as the charge which an atom of an element have when they are present in the combined state in a compound. Okay. So, oxidation number is defined as the charge which an atom of an element, okay, which an atom of the element appears to have when they are present in combined state in a compound. Okay. This oxidation number can be a positive value, 0, or negative value. In some cases, oxidation number will be a fraction. Oxidation number will be fraction value. Okay. Now, there are certain rules for assigning the oxidation number to an atom. Let us discuss those rules. So, general rules for assigning oxidation number for an atom. Okay, first rule. The oxidation number of an element in free or elementary state is 0. Okay, oxidation number of an element in free or elementary state is 0. Example, in the case of oxygen, O2 molecule, it is in the elementary state. So, the oxidation number is 0. Okay. Second rule, oxidation number of a monoatomic ion is equal to the charge of that ion. Okay. Oxidation number of a monoatomic ion is equal to charge on that ion. Okay. Example, in the case of Cr3 plus. Okay, Cr3 plus. So the oxidation number is plus 3. Okay, charge on the ion. Oxidation number is plus 3. Next, third point, oxidation number of fluorine is minus 1. Fluorine, oxidation number minus 1. Okay. Also, in the case of halogens like iodine, chlorine, bromine, etc., oxidation number minus 1. But when halogens, when they combined with oxygen, they get positive oxidation state. Okay, with halogen with oxygen, they have positive oxidation state. For example, HClO. Here, plus 1. Chlorine is having plus 1 oxidation state, oxidation number. Okay. Next, this is an oxoacid. Other examples for oxoacids are HClO2, HClO3. All these in all these cases, halogens, chlorine is having positive oxidation number. Okay. Next, fourth one, hydrogen is having plus 1 oxidation number. Hydrogen. Oxidation number +1. Okay. But in the case of metal hydrides, hydrogen is having oxidation number -1. Example, in the case of NaH, then CaH2. All these cases, oxidation number -1. Okay. Minus. Next point. Oxygen containing compounds have oxidation number -2. Okay. Oxidation number -2. But in case of peroxides, example Na2O2, oxidation number is -1. Okay. Now another example, OF2 containing oxygen. Here the oxidation number is +2. Okay. Oxidation number +2. Next point, in alkali metals have oxidation number +1. Oxidation number +1. Okay, +1. In alkaline earth metals, oxidation number +2. Okay, oxidation number +2. Then in the case of aluminium, oxidation number is +3. Okay, +3. Next point, the algebraic sum of the oxidation numbers of all the atoms in a neutral molecule is 0. In a neutral molecule, algebraic sum is 0. Okay, algebraic sum of all oxidation numbers, okay, is 0. Algebraic sum of all the oxidation numbers is 0. In the case of complex ions, the sum of the oxidation numbers of all the atoms is equal to the charge on the ion. Okay, in complex ion, the sum of oxidation numbers of all atoms is equal to charge on the ion. Okay. For example, in the case of SO4 2 minus. In this case, the sum of the oxidation numbers of sulfur and oxygen will be equal to 2 minus. Okay. Next point, in binary compounds containing metals and non-metals. Containing metals and non-metals. In such cases, metals have oxidation number. Metal oxidation number is positive. Okay, positive, and non-metal oxidation number is negative. Okay. Example, in the case of NaCl, metal oxidation number +1. Okay, here -2. Okay, in the compounds containing metals and non-metals. Next point, in binary compounds containing non-metals, both the atoms are non-metals, containing non-metals only. such cases, less electronegative atom have positive oxidation state. Less electronegative atom have positive oxidation state. Okay. And more electronegative have negative oxidation state. Negative oxidation state. Okay. Take one example. Example, ClF3. Here, in this case, both are non-metals. Here, fluorine is having -1, so chlorine is having +3. Okay, more electronegative fluorine is having negative oxidation state and chlorine is having positive oxidation state. Another example, ICl, -1, +1. Okay, like this. These are the important rules to find the oxidation number of different atoms present in a compound. Okay. Next is stock notation. Stock notation means the oxidation number, or we can also call it as oxidation state. Oxidation number is also called as oxidation state. Okay, so oxidation state of a metal is sometimes represented by stock notation. So what is stock notation? The oxidation number is written as Roman numeral inside the parenthesis after the symbol of the metal in a molecular formula. Okay, oxidation number can be written as Roman letter, Roman numeral. Okay, can be written as Roman numeral inside the parenthesis after the symbol of the metal. Okay, after the symbol of the metal in the molecular formula. Example, Fe2O. Okay, here Fe is iron. Okay, so its oxidation number is written inside the parenthesis as Roman numeral. Okay, after this iron. Okay, next another example, SN4Cl4, then Mn4O2, etc. are examples of stock notation. Okay.